So the next thing is a person I've been knowing for a long time. Works for Markönig, now for more brands. It's the Hemro Group, so it's also Ditting and I forgot the third one. Yeah, the one in Milan and Film, yeah, and all right, okay. Christian works as a sort of technical marketing, it was called to begin with, so it's more like communicating to the market about technical issues, but also collecting information from customers to make their products better. And the best thing they ever did was to find an old grinder. That was fantastic. No. So that's fantastic. So welcome to Christian Klatt, an update on grinding. Thank you very much.
Yes, so how do we start? We call it the latest on grinding, update on grinding, news on grinding. When I looked back on the internet for the speech I did 2 years ago, it was called the same, I think, or news on grinding. So I painfully went through it. I hate myself. I hate watching myself giving talks, so it took me a while with stops and breaks and drinks and continue and try to, and there are some mistakes in there. So who was there 2 years ago? Not too many. Or we've seen it all online? No, same. So no, I talked about heat in grinding, and actually after that talk we did a cupping together with Tim as well, prepared of different grinders, the EK43 against another grinder, and we compared extractions and taste of the same coffees and so on. But today I want to keep the presentation as short as possible, like 15 minutes, so we can continue the debate. Maybe you can ask more interesting questions than about topics that I didn't touch. So I want to quickly start on a couple of corrections from 2 years ago. And I will come up with these topics again in the presentation. It's just 8-9 slides. I think the main thing that is around, cheers, that is around the industry, and then it's getting more and more clear that, and it's mainly about temperature in grinding and how we have to work with temperature in espresso grinders and grind-on-demand grinders that get hot the more you use them. You can preheat them or cool them, and there's lots of different systems in the market. And the one thing you all have to know is that actually the grinder, the distance between the discs, the burrs, I will call them discs from now on, is not changing because of heat. Okay, so actually the grinder stays really constant. It heats up, yes, and that creates problems or things you have to, as a barista, and you have to react to. But actually the disc gap doesn't change, or very, very little. Very, very little, and it doesn't really, it doesn't influence the particle size so much. There's other things that are happening. The beans are heating up and behave different between the discs. And there's different research on that, and so we learned a lot, we listened a lot. So we always, with Markönig and also Hemro Group, which is Markönig, Ditting, Anfilm, and Chinese brand Hey Cafe, we were always very, very keen on seminars. We always told what we know. We wanted to talk about what we know, because if you share, you get shared back, and people will tell you their experiences and so on. So I want to know all your experiences, because we learn and then we can go better together. We can find partners to work with, like Morten now, like we work with us at HAB in Zurich with Can Juretian as well and Marco Wellinger, and more with the SCE again. So, and only if we all join forces, and also if other manufacturers join, we can actually find solutions like Morten presented this morning, which was again amazing. So we have to continue, and we do some R&D. We do well, actually a lot of R&D, but in-house we do a little bit with universities to get the official error-free results, unbiased, and try to incorporate that into our grinders. So I guess, yeah, the key in grinders is really consistency, like everywhere in green coffee, in roasting, in grinding, in brewing. And everything got much better in this. The espresso machines, the brewers, the water boilers are super consistent. Grinders kind of came out in the last years as being kind of a weaker link. But we need consistency in dosing, temperature, particle size distribution to keep the same, also to use that consistency in the machines and keep the numbers the same so the machines can do the same. And the second big movement and big development we see in grinding, which might not have grinders, which might not have to do too much with grinding, so coffee quality, but that's connectivity. It's very important for the bigger guys, not the single coffee shops, but for the chains, for the ones that in the end pay the big amount of the bills. And so they need all the information, all the data in their databases, and connect all coffee shops they have around the world and keep that easier and to predict better coffee. So we need coffee input control. They need all that data also to monitor loss or stolen coffee or whatever. It happens everywhere. They need to control the return on investment for the grinder because they might give the grinder for free. There's more and more influences in that. Grinders used to be free in the 70s, 80s, 90s from Italy because they were just cheaper and easier. So the roasters could give them for free or at a very, very low price with the machine, with the coffee. That was the model. And now that we have independent grinder manufacturers, espresso grinder manufacturers, that produce or grind on demand grinders are more expensive. You cannot give it for free as a roaster. But the coffee shops don't want to pay for it or don't have a budget, and so we need to make sure that still there's some kind of return. So we need to link the roasted coffee to the grinder, so they can't use cheaper or different coffee. And of course, service and maintenance needs to get easier and more monitored and so on. So I think this is again has nothing to do with grind quality actually, so taste, but this is a big thing now with several competitors or several grinder manufacturers, and the race is on. Who is first? Who can consistently build that grinder and build that feature? So the grind by weight thing. So you actually know you adjust the grinder by weight and not by time. All right. So and to get the accuracy, the consistency, right? So it's plus minus 0.1 gram, which is less than a bean. So that's the accuracy you need for nowadays espresso machines, because they also have the accuracy. They also do the gravimetric thing, and we need that in grinders as well. So it was presented at Host last year in October. Now we're in field tests. I can only talk about ourselves. We're in field tests. It's working really well. It's working really well, and of course with all this data you get from the scale, you easily connect it to some Wi-Fi system, and then you easily get all the data you have, like how much coffee you've ground in, how many minutes, how many hours, how many days and months and weeks. And that opens up that whole picture of connectivity and data management. So this grinder is much more than just a coffee grinder. It has kind of its own server, and then you connect it through a cloud into the roaster server or our server. That's also then a new service that we from Hemro Group will start providing all that data management as well. Heat, I want to quickly touch on and then maybe wait for your questions later. Well, the main thing is consistency, and if it cannot be consistent, we have to give some hints what's happening, so the barista who knows his machine and his coffee, or her coffee, or her machines, knows how to react. Okay, so we need to monitor it, and we do, so we know what's happening. And as I said, the grinder does not really change, but with the heat, right? But nothing mechanically changes. The gap stays the same. but the impact on the coffee. And since the coffee is in the chamber, touching metal, the discs, the ground coffee is still in the chamber somewhere, there's some residue, this coffee heats up, and this coffee reacts different when it's brewed. Okay, and there are more and more researchers going into that. You might know Chris Henton's paper that has been officially published as a scientific paper on freezing beans and room temperature and then heat up beans and the impact on the particle size distribution. And funny enough, we kind of did the same thing at the same time in Zurich with the university last year. And we didn't really go minus 100 something with liquid nitrogen. We just used a freezer, room temperature, and an oven, 3 temperatures that might actually be relevant for coffee shops that everybody can actually use. And this is a quick result on particle size distribution. So what we did, we dialed in an EK43 in room temperature with a certain coffee and dialed it in for perfect extraction with 20 grams in, 40 grams out in around 30 seconds to give us the best result in the cup for that coffee. And then we kept that all the same and stored the coffee at these 3 temperatures for a couple of hours and then took them out of the freezer, ground them as quickly as possible, these 20 grams, and brewed them as quickly as possible. Didn't change anything in the grinder, just we wanted to see the difference. Only the bean temperature actually has on the whole system, actually only on the grinder first. So that's kind of the same thing that Chris Henton did. And that brings us to the first question again that Morten came up with, and I think that's the topic we've been touching several times this week. Is are we actually measuring the right thing? Are we actually looking at it in the right way, in the best way? So we have the 2 different graphs. This is volume percent, and this is surface area percent. So this is the integral of the surface. So what's more important, is it volume for extraction or is it surface, where the water is attacking the surface? We've always, in my clinic, we always had these graphs, volume percent, so to the power of 3, and this is only the power of 2. And it then, in recent years, it became more and more clear that the fines are actually not evil. We have to use them. They're actually extracting much faster, and we're getting more intensity out of the fines. So first we said, we need the fines in between the cores to slow down the espresso shot, and nowadays it's like, yeah, fines are great, but we need the cores to get the water through somehow. So it's a different approach. And this graph actually shows the fines much better because it it shows bigger differences. I don't want to go into detail too much because I'm also not too much of a scientist, and we have to work more with people who actually know these kind of graphs and know the statistics behind it. But questions, lots of questions about how to actually approach all that. So what came out of that test is that, well, yes, frozen beans are more brittle and break into smaller pieces, to keep it very, very simple. And so more fines and also less coarse, of course, just coarse particles. So that's the simple particle size distribution. And then what we did, so I should actually go the other way around. This is what we found in the cup. Not scientific panel, not 60 people, not even 12 trained and real panel. It was 3 of us, just in the lab tasting these espressos. But we can see a very, very easy direction. But of course not scientific and not error-free. And then what we then also did is we took these espresso and analyzed them with a gas chromatograph, I think is the word. And this came out. And also, again, I have to apologize that I can't say too much about it. Not that I'm not allowed to, but I just don't know too much about it. But you can see also the direction. So it's all the red ones are minus Yeah, plus 25 relative to the frozen one. So you see positive change, positive differences, deltas, and that's the plus 65. So kind of overheated, going through, pretending to go through a hot espresso grinder. And you only see kind of negative deltas. And the ones like the aromas here in the front are very easily volatile, so very volatile, and the ones here are more, less volatile. So the hotter the coffee gets, so the 65 relative to the frozen, you kind of lose all aromas. So the coffee has way less aromas, the espresso, so espresso tasting. At 25 degrees, plus 25, so room temperature, the difference wasn't that big. You lost these less volatile, but actually some were even higher. So there's, again, we started that project, we started a little bit insight into that, much more to do. That's actually everything I want to just give you a short insight in what we're doing in connectivity, electronics, and data management, and also in grinding to find out more. And no, thank you first for listening.
Thank you, Christian.
And so yes, almost 15 minutes. So, but I think I always like these Q&A sessions much more. I enjoyed the Q&A box.
You got 2 minutes.
We started late. Depends on how many questions are coming.
Hi, do you make industrial grinders?
Mm-hmm.
Okay, talk to this.
Yes.
Thank you.
Oh, that was three different versions, and we are doing much more projects about that now. Until now, we kind of sold them kind of passive.
Okay.
When there was a question, we could yes, we have, and we offered one. And now we're going more into the packaging industry, talking to packaging machine manufacturers, and they're actually very happy about these smaller versions. So it's still flat disc grinders, with maximum capacities up to 400 kilograms per hour, starting at 100, going up to 400, and you can grind 24/7. So perfect for these capsules, and so on machines. And yeah, slowly touching from the bottom into the roller mill industry, like from Probat, but at a lower price. So actually, finally, we can also work with Probat on some projects. And it's interesting, very interesting.
Damien?
You said something about heat and expanding of metal.
Mm.
Did you say that because of associated only with Marconi grinders, or in general, like
No, I think
bars are not expanding?
We haven't tested other grinders too much. Of course, we have, but not too much. And really, they're all really consistent. So if you heat them up and then throw in room temperature coffee, it doesn't change.
Okay.
Okay.
But if grinder works, for example, 6 or 8 hours, I had this problem with matter. The metal thing which is keeping the bars expanded that much that it started scratching the surface around, and it stopped working at some point. So that's why I'm asking if it's associated only with Marconi grinders, or?
No. Of course, the material expands a little, and there's a little bit, and there is also a little change in disc gap, in the gap, but not as much as it would explain the difference in shot time that we are experiencing when we're using a hot grinder. So, and yes, if the tolerances are very small, then suddenly some metal parts might be touching each other that should not, and then it blocks. And that depends on conical or flat, or the manufacturer, on how they do the grind chamber. So there are, yes, it might happen, and threads block up when they get hot, but that might also be because the lubrication in that thread might not be that heat consistent, so they get more liquid, and then they run out of the thread and leave the fixed particles they have in there to get rid of the last plate, they leave them in there, and then it blocks. So that's then kind of mistake by engineering, but by the engineers. But the heating of the metal does not explain the difference in shot time. That is because the beans are sitting in the grind chamber that is 80 degrees, 100 degrees sometimes, and the longer they sit there, the hotter they get. And then you grind them, and then coffee is more malleable when it's hotter. So that's a new vocabulary, less brittle. Just behaves coarser.
Another question here.
I have seen that cold brew, is getting very popular. Have you analyzed how grinding may affect if water is cold instead of hot?
Yes. Well, we have, because of the cold brew movement, we have introduced different grind adjustments for the dipping range, for example, where you can grind coarser. But that's only for full immersion cold brew. It's not for the drip Japanese version, right? Where it drips. There are so many different versions of it. I can't really say anything specific on how grinding influences that. The general grind size, yes. So for different cold brew methods, you have to grind either medium or very, very coarse. But if we need a completely different particle size distribution, I don't know.
I have a question. Have you done any measurements on burr alignment? So burr alignment on EK43, for example, and how it affects what you were just talking about with both types. I haven't seen this other type of measuring particle size distribution before.
Yes, we tested, and we put shims and metal foil and and tried to see the difference, and we didn't see a big difference. Of course, if you really look for it, you might find a difference. Doesn't really translate in a big taste difference for you as a roaster or cupper, or even for the customer. There are so many other variables on that we believe that on a business point of view, in our production, in our assembly, we are doing the utmost we can in production of the surfaces and the accuracies and the tolerances in our production process, and also in the assembly line, that they work so accurate and so spot on that we're doing up to now the best we can to keep these burrs aligned in terms of parallelity or whatever, and also the vertical vertical alignment, so they're really on top of each other. That's the two things that has been discussed on the internet on diverse channels, how to align the EK or any other grinders. The Mythos is coming now as well more and more with these videos and so on. So definitely is a point we have to focus on, and we're optimizing the EK slowly. It's a very old grinder, we have to do it very slowly and see the effect and test it for quite a long time if it has an influence, and coming up with a tool so you can actually screw the burrs, the discs, centric, and so on. But since it's an old grinder with old production methods behind it, or cast aluminium, cast steel discs, and so on, it's also, we're actually investing a lot in the production process, in the casting as well with our suppliers. And there's not too many cast steel suppliers that can actually work that accurate. It's very interesting which fields we're actually scratching now, suddenly.
Yeah, I've got another question.
I promise this will be really quick. And this is a pretty specific question, and I don't know if this is applicable for you to answer, you probably know, but how often would you recommend cleaning the EK, as in taking off the front plate and cleaning it? And how often would you recommend replacing the burr set, as per like however many hundreds of thousands of kilos? I don't know.
Cleaning depends. Difficult to say. Yeah, how many different coffees you're using, how often you change grind size, how accurate you actually want to work. I mean, if you're looking at the last tenth of a gram or hundredth of a gram, I mean, you should clean every day.
I've seen some people that never clean it, and then I've seen some people that do it every week. I've never seen anyone do it every day, but.
Well, there's lots of shops cleaning their espresso grinders every day.
Oh, not the espresso, I was thinking
But
more like the
EK, yeah, but still, I guess it's you should look at it the same way. Although it's always empty, and you can change coffees very quickly, maybe with a little purging or even without purging. But I wouldn't recommend every day because it will wear and tear, and you might do more things wrong than you're actually helping cleaning it. But yeah, I can't really say. It's really up to you. You realize when coffee is starting to build up because of oils, because of fines, and then you use the knocker or the back holder, and then you see the clumps falling out because after 2, 3, 4 days, maybe there's been some build up. Depends on your coffee, how oily it is, how many fines, how many, yeah. And burr disc lifetime, well, there are general numbers we say. Me as from the factory or from kind of, or from the customer point of view, I always want to tell the real numbers. Like we say for the espresso grinders, 65 millimeter, we say 800 kilograms. It might be 600, it might be 1,000, so there's already a gap. I know lots of different customers who have these numbers 600 or 1,000 or even 1,500 kilogram, 1.5 tons, and I believe them that they still get the perfect quality out. So there's already the gap. And if you go to the EK with tools like cast steel discs that are harder and they last much longer, this gap goes even bigger. So if you grind light roast, always very fine, worst case not too clean, I don't know, maybe not in this room, but in the broader field, then of course they wear much faster, then they might be going after 4 tons, 4,000 kilograms. If it's darker, very clean, you might go up to 10 tons. And you only grind filter coffee. So again, that gap goes bigger. But I would say, yeah, 4 or 5 tons, 6 tons, really depends as well. Also, it's difficult to measure. Again, I always get this question a lot, how do you realize that you have to change your discs? Speed, heat, sound, spraying, TDS. Yes, if you do your QC all the time with that grinder, you know how it's reacting.
Do you think you might include this information with the new product that you guys are developing? I mean, considering it is going to weigh the lifetime of the coffee that will come out of that grinder?
With the grinder weight or with?
Yeah.
Yeah. Well, we have all our software-driven grinders, so with timer and so on, they have disc change timer or disc change counters, but that's shots, numbers of shots, single shots. So depending on how you set your single and your double shot, that gives you more or less coffee. But it's counting with a 16-gram double shot or 8 single shots, that's 100,000 shots for 800 kilograms. So that's what the K30, for example, is set to come up with the alarm for this change. If you set 20 grams, then it's a little, of course, then it's 100.
All right. Thank you very much, Christian. Thank you very much for the questions. Thank you.